This guy? Same type of thing. I mean, if you wanted to create this guy, that means I got a good way to figure it out. I know how to do it. I think. If we wanted to, we could, and I guess we want to. I don't really want to, but I will. We can. There's an H right there. We can figure out the R and the S here on that carbon. Okay, and it is. It's S. Okay, so that's S. That's a hard one, by the way, if you're figuring out R and S. You know, fair game, but that would be a tough question. In any case, that's S. Okay. This guy, this is a little dangerous with the let me make sure that I did it right. I did that one right. So, yeah, that's R. How? This is a specific enantiomer. I'm starting with one specific enantiomer, and this specific enantiomer has the R configuration of that carbon. Okay. There's no chemistry I've taught you really. I mean, well, there's kind of is that would convert that to an S. Okay. To convert that to an S, we'd have to make him a leaving group. You actually could do that. Make him a leaving group, and then attack this with hydroxide, and then you get inversion. Oh, but then this would be slash 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 slash, and that guy is on the wrong side. Okay. Still bugging you. I can see it.
Well, I can picture myself still doing both on the test.
I'll take very little points off. I will take very little points off.
Okay.
Is it better?
If hang on, most of the time, you always got to cover your bases and protect yourself. That's what the lawyers tell you. Most of the time, if you start with a specific enantiomer for your starting material, you will get a specific enantiomer for your product. The ones where I've taught you, oh no, you get both, don't forget to write both, you're not starting with a specific enantiomer. You're actually starting with something that's not even chiral. It's got two sides that can react. But in these, you're starting with a very specific enantiomer.
Is it better to include, if we're doing that bottom one where it can only have, it's either in one room or the other, is it better to include that second answer, or if we have an equation where we don't think there's both, just include one? Is it better to include both if we think there's both, or hold one back?
You mean when in doubt?
Right.
Oh. Just do the right thing. You know, it's the main points are knowing the product, knowing the functional group transformation. We get an epoxide from this reaction. Is that the right time?
No.
Oh, it's not.
Like 10 minutes after.
You can't mess with me, by the way. You get me in so much trouble.
It's
Quarter
4:15.
15.
Yeah.
It's what?
4:15.
Quarter after 4.
Yeah.
4:15. Okay. Okay. Should I show you a neat thing having to do this, or should I shut up and get on with it?
Shut and get on.
Sometimes I need to be told that. Any other questions? You want me to keep doing this kind of stuff?
Keep going.
Yeah,
I
are
really
there any
enjoyed
other
this.
key shortcuts?
We all do notes.
You know what I always do in finals week? You know what I always wanted? And there wasn't even the clicker movie back when I was doing this. There was an old movie that your parents remember called The Girl with Gold Watch and Everything.
Oh, I've seen that.
Come on.
I have. My dad and my mom follow these kind of like old vintage movies. And
It was a made-for-TV movie.
I
Like,
know, but they taped it.
how funny.
Like, my
Anyway,
dad
this guy had a
and
gold
mom
watch,
taped
and if he clicked the button, he stopped time. And everybody else froze, and he kept going. I get every single finals time in my life, I thought about that. I thought, how great would that be? Just click, I'll take a nap for about 10 hours. I'll get some food. And then I'll study. I'm not going to take advantage of this, which I'm sure I would. 2 weeks have gone by, okay, I should unfreeze the world. Yeah, sorry, what was that? That was going to be my smart ass answer. Was, a nice shortcut would be a time machine. That's the first. Yeah, you guys did great on the first exam, so maybe. And I don't know what it was. I would actually say you guys did better on it, on all the SN1, SN2, that stuff from exam 2 than you did on the reactions of the last one. I don't know if it's a handout I made that just makes it super clear, cut and dry.
Forgot why.
What's that? No, come on, do that. You know better than that.
So wait, for the final, is it pretty much just going to be like a bunch of reactions like this and you have to find the products?
Could be.
Yeah.
I like problems where you also have to sometimes figure out the reagents.
Okay.
Okay, so here's the starting material, here's what I want to make. What do you need to treat it with to do that?
So like the second one of the last exam.
Yeah.
Okay.
But if you know the reagents cold, that's not going to be a problem for you.
It's all stuff that you
I mean,
see,
what if I went? I don't want to put that there. What if I did that? What should go on the line?
So it'd be NaH or KH.
MGPBA? Yeah.
MCPBA.
Wait.
Sodium hydride is when the starting material has an OH and a leaving group.
Just kidding, we just did this, yeah.
These kinds of equations that you're giving us though, whether they're on our notes or not, we've already seen them now.
They're not, like, you're not gonna just pick a random,
Yeah.
Oh,
Yeah.
here's, okay.
No,
Wait, what?
stuff you've seen. Stuff you've seen. I mean, to be honest with you, we haven't learned that many reactions. Certainly for chapter 9 and chapter 12, I think right now you could generate the note cards for them. And you could do that in an hour and a half, I think. And do you remember my way of, and this will help, concerns with this type of problem. You remember my tricky way of doing note cards?
Yeah.
Put the product on one side, like the whole thing on one side.
Basically put this on one side, okay? And then on the other side,
Just
put,
the left and the reactant.
That
Yeah.
reagent.
And then have the goal.
that way you can use either side to test yourself.
Question.
Yeah.
Do you write up the finals yourself, or is it a standardized thing?
No, I wrote that. I wanted to give you the standardized exam we have. We just didn't cover enough material. And there would be so much stuff. And what I always do, I mean, I always curve it when I give that exam. I always curve. We typically give it to the 2-semester class, and we always curve it. And I could give it to you, and then nobody would do super well directly, but I would curve it, just like a standardized exam, I took an exam in grad school, they made me take an exam, and I got 50% right, and I was in the 90th percentile.
What?
Right, I mean, that's the way.
That's a really terrible exam then.
It was awful. And a terrible subject, physical chemistry, it's the hardest thing I ever. But there's a lot of exams in your life that are like that. You guys are probably going to all go to grad school, whether you know it or not. You're going to take the GREs, and GREs can be like that. A lot of stuff, and you have to learn to, just see. Okay, I don't know what that is. Boom, I'm not going to freak out. I'm going to move on. So I could have done that, but I mean, it would have been too easy to freak out. There would have been like maybe almost half, not half, but almost half of the problems we hadn't gone over. That would flip you out.
I think you would have seen at least one mental breakdown in that exam period.
I've had tears. My first semester of teaching, you just don't know when you make these tests. You really don't. You don't know. You have an idea, but you don't know if it's hard or easy. You try, and I handed out an exam, and I said, "Guess what, guys? This is my easiest exam." And did I tell you this story? And I handed it out, and it was the hardest exam by far, and I just had people cry. Like, what a jerk! What a total jerk!
Did you give them like a read too, like a different exam to take again, or?
No, I just curved it, and they ended up doing fine. You know, it just was a very challenging. What's that?
You just watched them cry while you're.
No, the tears mostly came after the exam and stuff, but I was like. And then I started emailing the whole class, like, I'm sorry. And I was like, okay, you know what, back away, don't email anymore. All right, so I could keep on, but we're not going over a lot of different reactions. We're going over the same reaction 5 times, so I don't know how to protect it. But that's kind of what I'm trying to show you guys. Like, you have to learn it, and then you have to be able to generalize it. And I think it's a matter of learning the core change. What's the core change that we get? Yeah. Okay. You want me to make up a bunch of problems, and then you give them a try, and then I tell you what the answers are?
Sure.
Okay.
What time do you need to leave by?
I need to leave this room by 5.
Okay.
Because by the time I get in the car, I have my computer and everything like that.
No.
I just noticed your shirt. That's so funny.
Oh, I know. My dad and I have matching ones.
That's hysterical. Do you stand in front of each other and go,
Yeah. No, but we match sometimes in public. It's really embarrassing, but it's really funny. Really funny.
that's awesome. Oh, that's really hard. Oh, man. Sorry. This is really hard. I don't know that part. That's good. from you, Lev?
No.
Okay. Exam 3. This is what we did on the exam.
POCL3?
Mm-hmm. Buckle. So what time is it now, Andrew?
It's 4:31.
Okay. So that thing is just like 10 minutes past.
Do you want to just borrow my watch?
No, I'll just, that's 10 minutes past, yeah. And I'll just use that. Yeah. That was super late yesterday.
And play some tunes in there for you, like last time.
So, I mean, I think if you guys, if you haven't made note cards for 9 and 12, do it. You know, it's, you can do it fast. You can do it in an hour and a half.
This thing gets heavy.
I don't, yeah. I prefer when I'm harassing students that they don't have them bound. And the reason for it is I want you to be able to take the ones out of the pile you know. Because I don't want you to keep on,
Putting your
and I like to be able to shuffle them.
I said I don't lose them. I lose the things.
Oh, right.
They sell these little things that you can get that will keep them organized for you. Kind of like a little, like a pocket protector? No, not a pocket protector.
It's like
But
an
it's
expandable
like
file
a-
for
Yeah,
documents.
yeah, like a document filer, but
But I mean, you know what? If you make the kind with the ring and you got that and you study them real good, you're still.
I mean, I can take it
Yeah.
apart.
Yeah, I wouldn't, that's the least of your worries in this class. I mean, if that's, but just so you know. And then knowing, and I think you guys did a good job of this, knowing that sheet that I made for SM1, SM2 and all that stuff, knowing what are the non-nucleophilic, what are the non-basic good nukes, knowing that list and stuff. And that does come down to rote memorization. And while you're going through and you're flipping those cards and you're looking at the notes and looking at all those things, it's good and helpful and useful to learn, oh, I got an OH, then get rid of an OH and a leaving group, and I see an NH, get rid of the leaving group and then make it through a group. If you can, at places, think about how it works. You know what I mean? If you get just too robotic about it, then you can get slipped up a little bit, Does that make sense? Try to think about how things work. That will keep you, Andrea, from like inadvertently, I'm making epoxide, I'm making both of them. If you kind of think a little bit about, again, you'll get most of the points if you have both of the epoxides, even though you should. Okay, should we go through them?
Yeah.
Go on from? Okay. Okay, so how do you classify this first one? And sometimes I think these problems are, I told you my concrete breaking analogy, right? Yeah, I know I did. When you got a sidewalk and you have to break up the concrete, go to the easy parts first, chip away at that. Don't start at the hardest part. So, okay, I don't really know what this is, but well, I do know. Gideon said when you have a salt separated. Okay, I'm not totally sure what kind of reaction this is. But, you know what? Azide, N3 minus azide is that's on my list of good nucleophiles that's not basic. This must be a substitution reaction. Oh, and look at there, I have a substrate that's got a leaving group. Okay. Okay, so what type of starting material do we have? Is that leaving group primary, secondary, or tertiary?
Primary.
What's that?
Oh.
So you look at the carbon where the leaving group is, and that's that carbon right there. It's secondary leaving group. Okay. So you have a secondary leaving group. What type of solvent do we have? I've indicated that here. No, it's solvent.
Oh. DNF.
Yeah, do you guys remember? That is one of the polar A protons. Okay, that could be a hint sometimes as to what this. If you didn't know that, you can still, don't be freaked out, you can still probably get the right answer, even if you're not sure what DMF is.
So that's an SN2.
It's an SN2 reaction, yeah, exactly. Okay, so somebody help me draw the product.
Well, you draw like the other one.
Yep,
Except you have salt and 3.
and what?
So you substitute with N3.
Yep, and
But
what
it will
else?
go into the
Ah,
other room.
yeah, it's an SN2 reaction,
That
so you're
tripped
getting
me up on the
version.
example in
What's that?
class. That tripped me up in the example in class.
Oh,
Because I
okay.
didn't have to go into the other room. I headed towards us, and you're like, that gets 9 out of 12 points.
Wait, I had it wrong on mine?
No, I did.
Oh.
And you told me that gets 9 out of 12 points.
Oh, okay, yeah.
And then I did it like that, and you said that's full credit.
Oh, okay, good. Make sense? Okay.
What do you do with them?
I don't care. I mean, ultimately, it's a byproduct.
Yeah. We're gonna have to-
Mother Nature doesn't like charges, so she's gonna bounce. Oh, hey, sodium lost its dance partner, and you're available.
But we get all points if we didn't include.
Yeah. Not a lot of places where the byproducts I'm gonna ding you for. Sometimes we have a minor product, on this SN1, SN2, all that kind of stuff. And I usually require, that's 3 of the points, 3 of the 12 points, or whatever the case would be. Okay, we have a secondary substrate. What type of solvent do we have here?
Alcohol.
Yeah, which is, what do we call that? Called protic. Okay, so we've got a protic solvent, a secondary substrate. Any thoughts what kind of reactions can happen? Remember, secondary is kind of the pain in that because you can get all 4 possible reactions. And if you go to that chart and you look at polar, good non-nucleophilic base under secondary substrate in a protic solvent, you can get both SN. First of all, it's going to be a 1 reaction, right? It's either going to be, because it's protic solvent, it's either going to be SN1 or E1. And in this case, it could be, you can get both. All right, so let me draw SN1 product. Anything, help me draw it. What do I need to do to draw the SN1 product?
You need to do benzene rings.
What's that?
You need to do benzene rings.
Draw the benzene. What else you want me to do, Julie? Yeah, I bet I gotta draw this other ring, right? We know that, nothing happened to that.
Then
You gotta attach the alcohol or the OH.
Let Julie.
The O2, the OTS, and put in the alcohol.
Exactly. It makes an ether. Any details about that?
It can go either way.
It can go either way, yeah. When it's SN1, it becomes a flat carbocation, and the alcohol can from here, or the alcohol can come from the other room. Okay, so we could get the oxygen itself is the nucleophile. It might be good, you wouldn't have to do this on an exam, but it might be good just to go, oh, you know what, I'm going to get a carbocation, and maybe that'll help you. That's kind of what I'm talking about, visualizing. Okay, and then that alcohol is going to come in, and it's going to attack that carbocation. It can do it from our room, or it can do it from the other room. Okay. And then, because it's not that good of a nucleophile, it's an okay nucleophile, but it's not on our list of good non-nucleophilic bases, you can also get some elimination in there. If it had been a good nucleophile like cyanide or azide or something like that, probably wouldn't really get any elimination.
The one on the top is the main one.
What's that?
The one on the top is the main one. Major.
No, if you look at the chart that we have, with this one, no real way to predict. Okay, how about this next one? Here's one, who wanted to just, oh, I really want to focus on the reagents, and that'll help me? Who said that? Yeah, that was you, right. There are some reagents that only have one purpose in life, okay? TB toxide only has one purpose in life for our class. In advanced chemistry, it does other things. Does anybody remember what's its one purpose in life? That's my job. E2 eliminations. E2 eliminations. Because it's a, normally if you have that's just a deprotonated alcohol. Normally if you have a deprotonated alcohol, it's a good nucleophile. But that is not a good nucleophile. So, oh, I don't have any energy. if it had just been, you know, this guy with just the methyl group right there, that would be a good nuke that's also very basic. Possible mixture of SN2 and E2. Because it's so bulky, you don't get any SN2. You only get E2. Okay? So now, I've decided it's E2. What do I need to do to get my product? What's the process you guys go through to write the right thing in the box? You know it's an E2. What type of product are we creating?
Elimination.
It's elimination, but what type of product is it?
Alkene.
Alkene. Alkene. We want to write an alkene. Where the heck do I draw the alkene on this starting material?
Someone put where the CL was.
And what else? Yeah, so where the Cl was, and adjacent, any place there's an adjacent hydrogen. Okay. Well, there's 3 hydrogens here, and there's 2 hydrogens here. Okay. So we could have either of those. Okay, we could have that.
That's not really
We
bad
have
now.
that. Okay. And this is hard. And right there, that's most of the points. Okay. But it's not all the points.
Oh, so you determine which one's a major and which one's a minor product?
Yes, but we're not even ready to do that. There's another product. You mean this one?
Yeah.
That's not adjacent.
Okay.
Adjacent has to be on next to. That's on the carbon. So that one will always be there. That is this H. And he never gets deprotonated. But when you have 2 H's on an adjacent position, okay, you have the chance of either of them being deprotonated. Okay? And you can get either type of stereochemistry, alkene stereochemistry.
Ah, I knew it was the funky one. Yeah, man.
Does that make sense?
Yeah.
It is actually remember that one.
Yeah. The E2 eliminations are a lot like epoxide formation. The proton that gets deprotonated has to be anti to the leaving group. It's called anti-periplanar. We didn't actually go into that. We just sort of memorized it this way. And I think actually that was a mistake. I think I should have gone into the anti-periplanar part. Okay. So because this is rotating, okay, it can rotate, you know, it's got that type of configuration, but it could rotate in this type of configuration, and then the elimination could happen. Okay. Did I draw the right product? I didn't draw the right product. Come on, Gideon. Well, I did, but I drew it kind of funky.
Does it need to go the opposite way?
Well, I should have drawn like that. That's a little bit more clear. Okay, of those 3, what's the major product?
The first one.
The first one, yeah. Why not him?
2 is more likely than the 3.
The 2, what do you mean by 2, Julia?
H.
Attached to.
That's actually technically true, but you need to know the reason why. Why is both of these? I would expect to get both of these more than this one.
Is it because there's more R's on that one?
It's alkene stability. Remember, alkenes have 4 positions. Every alkene has 4 positions. 1, 2, 3. Okay. This isn't to be mistaken with primary, secondary, tertiary carbon. That's when you're talking about a specific carbon. Here we're talking about an alkene, which incorporates 2 carbons, actually. Okay. And every alkene has 4 positions. Mother Nature likes those positions to be filled with carbon things. Okay? So this alkene, 2 of the 4 positions are carbons. Okay? You can look at the alkene and identify that's 1 position, 2 position, 3 position, 4 position. Okay? In position 2 and 4, they're carbons. So that's a di-substituted alkene. Alkene. Okay? This is also a di-substituted. This is a mono-substituted. You get that, Julia? See that? Okay. Mother Nature likes tetra-substituted is the best, then tri, then di. And of the di-substituted or the tri-substituted, Mother Nature likes big things on the opposite side. Mother Nature prefers this to this, just for steric reasons. Okay. I probably should have added a solvent here. CHEM, which is polar aprotic solvent, okay, which favors our 2 reactions, SN2 and E2, okay. What type of reagent is that weird alkyne-looking thing? That is, that's on our list. I think, you guys feeling freaked out? You got a little freaked out look on your face. This is why you're freaked out. Because I wrote a whole lot of problems from exam 2. And that's a little bit more rusty in your mind than the exam 3 stuff. You guys did well on exam 2, okay? And I think you did it by learning that worksheet that I handed out. So we need to get the dust off that that whatever it is, 2-page worksheet that I created. You know, that tells you when things are going to happen, okay? If you know that worksheet real well, that will stick out like a sore thumb. Oh, that's a good nuke that's also very basic, okay? All right, so we have a good nuke that's also very basic with a primary leaving group, okay? You're going to get mostly SN2. A little bit of E2 possible as a minor product, probably will. So, to draw it, we get rid of the leaving group. The other stuff stays the same. Okay. And that lone pair is going to make a connection to the carbon where the leaving group was, which means it's going to be a bond like that, which is that lone pair, and then those guys. And then that methyl comes along for the ride. Okay? Yeah. This is just, yeah, we had done earlier, we had done a lot of exam 3 stuff. And so I wanted to do some exam 2 stuff. Just go over the notepad, or go over the worksheet.
Your 9-minute one.
Okay, thank you. That would be a byproduct. Remember? If we know that E2 is going to be a possible minor component, then you draw an alkene between the carbon where the leaving group was and any adjacent carbons with adjacent hydrogen right there. Okay. DBU. Debut.
Bulky.
What's that?
It's bulky. I remember that one.
It is bulky. But I don't even think I talked about the fact that it was bulky.
No, it's not tertiary.
It's got one purpose in life.
E2.
E2. So actually, the E2s are t-butoxide, DBU, and DBN. So all they do is E2 eliminations. Okay. They're not the only thing that do E2 eliminations. Heck, this thing just did a little bit of E2 elimination. So you can't say all E2 eliminations are going to be by one of those 3 reagents. What you can say, if you have one of those 3 reagents, it's going to be E2. DBU, DBN, or t-butoxide. Okay. All right. How many products do I get with this?
3, 4.
Okay, I got to vote for 3. I got to vote for 4. Well, look at it first before you answer. Okay, how many? Look for the adjacent protons. So you go to here's the carbon with the leaving group. You go to adjacent carbons, which are carbons next to it, there, and there. And what, Dan? And up there. That's the tricky one everybody always forgets. There's probably almost just like that with Dan too. Okay.
So you get 3.
Well, this might be one. Yeah, okay, let's say. Well, shoot, just draw it out. Heck. Does that look good? Did you shake your head or nod your head? Ian?
Well, do we need stereochemistry, or is that irrelevant?
No, because this one could do this little rotation deal and give you another one. When it's cyclic like that, there's no rotation that can happen. Okay? So we're good? What if I told you I'd probably mark off a point or two?
You have to list the major and minor product.
Oh yeah, that's a good point. Yeah, I'm probably required to do that too, but that's not actually what I was getting at.
They're the top two are the same.
The top two are the same. It's the same product. And I want you guys to recognize that. Okay. Do you see why they're the same?
So then you would only need to list one of those.
What's that?
You'd only need to write, like draw
Yeah,
one of those.
only list
plus
one
the
of
other
those. So the ideal answer for this problem, again, don't give up. Fight, 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 and don't leave blank ones. Drives me crazy. I'll track you down. I'll make you put something in that box. You know, try your best. Don't give up because there's a lot of partial credit that I can find in these things. Okay. And repetition. I don't care what your approach is, whether it's note cards repetition, whether it's looking at the notes and reading them over and over and over and over again. Get yourself a 5-hour energy drink and just read them over, read them over, read them over. Repetition, 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 repetition. That's the key. Okay. This stuff isn't that hard. Drawing a little triangle with an oxygen in it. You know? And that's what we're talking about. There's just a lot of it. The individual rules are simple.
5-minute
So, okay, thank you. The ideal answer, this would be the major, right? Because how substituted using the right descriptive language for alkene stability is that mono, di, tri, or tetra substitute, the one I circled. Tri. Everybody see that? Tri, 3 carbon groups? Oh, beautiful. Anybody remember what PBR does?
Gets you really drunk.
What's that? PBR. What's that?
That's
Half fluorine and decadium.
Yeah.
Right. Boys, nice when you get a real job and you don't have to drink beer all the time.
I've been waiting to pull that joke all semester.
That's awesome. You know I'm going to steal that from now on for the rest of my career.
That's good. As long as you
What
attribute
is
it to
this?
me.
Other than a beer to get you through it. 20 years from now.
As long as you remember my name, that's okay.
Absolutely. Andrea, I suck at last names clearly, so especially yours.
It even said Andy on it.
What's that?
It said Andy on the test.
Oh, did you really?
Yeah.
I didn't even look at the name, I just calculated the score and I was like, and he was like, Norwood. Oh, wait, what? That wasn't mine?
Thank God you both did well. I mean, I think once in my life I've given, you know, oh, here you go, there's your A, and oh, sorry, here you failed, or whatever. Oh, so sorry. I've done that once in my career. I know, I should have been fired. Okay, other than a cheap beer you buy in college, what is PBR?
Substitution?
No.
It attacks from the backside.
It does attack from the backside. That's weird because nobody knew that, or maybe people knew that but didn't make the next jump in logic that they had to make.
I got 8.
But what does it do? It attacks from the backside. But what change do you make? This is and this is just rote memorization.
Change the configuration?
It does change the configuration. That's what she was saying. But what does it just change this to an alcohol that's pointed back?
No,
No.
the BR.
Yeah, it changes, yeah.
Yeah.
So what
Well, nobody had said that yet. I mean, I know it, I know it's not hard.
The
Substitution.
BR says.
They're not substitution with the BR.
Like in SN2?
Alright, we all got it, everybody gets full credit. Okay, so the product should be, and, oh, come on. Okay, and also, how do we do it with chloride, if we wanted to make that a chloride? Yeah, we could do it with HCl, but that's a sucky way. I told you that was a sucky way. What's the other way we can do it?
POCl3.
What's that?
The
No, POCl3 does not do that, and students mix that up. It's SOCl2. And it also does it with an inversion of configuration.
That means it's SO2.
Yes, exactly. So SOCl2 would create the alkyl chloride, okay, with inversion of configuration. Okay. Oh, okay. This
So wait,
is
does
why I
that
get
get
in
you the
trouble.
full points?
What's that?
Got time.
Okay. Okay.
No, I mean like, no, it's like time, 15 seconds, so.
Oh,
Fine.
I'll be
Well,
all right.
technically you have
I'll be
2
all right.
minutes.
I'll be all right.
Will that get you the full points if you
That
want to
get you-
have
Yeah.
the PBR 3 as a,
So that's full points.
No, full points.
yeah, okay.
Yeah. But what was the answer to this one? This was, remember I said 1/3 cream puffs, 1/3 reasonable, and 1/3 challenging? That was a challenging one.
That even means,
No, it doesn't react. Why not?
because it's too thick, it's too cold.
You can't do an SN2 reaction on a tertiary center.
Yeah.
So that was the no reaction. It's a little tricky.
Or a portion time.
Is the movie, is the video still going?
Yeah.
Okay.
Oh, there's video.
Oh, yeah, it's going up on YouTube. Yeah, no, you're all good. This is gonna be so long though. I should have had you stop it and then press start. It's gonna be too long.
You can still
Right,
upload
it's
it
been
to-
2 hours. I can't
You
play
can edit
this.
it.
You can still, you can
Just
still
pause
upload
it
it
on
on
iMovie and then just chop. It's easy.
Or you can
There's
just
so many
upload
reasons
it.
why that can't happen.
You can still upload it to YouTube, like you can still do that. It'll
Yeah.
just take a little bit more time, but if you upload it at a lower resolution, then you'll be fine.
Okay.
Yeah.
Alright, hopefully you can see the board. Alright, will you press stop now, actually? And then just, so.
The little gray
I don't know why that's stupid I'm doing that. It's just gonna, no, it's actually this dude right here, the red one.